Alright, so welcome back to OneClass again. My name is Joey. I'm going to be your math teacher for this session. Again, if you're tuning in for the first time, thank you so much for watching. What we're doing here at OneClass is we are providing free online resources, some online material for specific subjects in math and in chemistry, particularly from basically high school math and high school chemistry all the way up to the university level, university and college level for both subjects. So that's kind of what our goal is here at OneClass. And what we're doing here is we are solving, what my job is we're solving chemical problems or solving solutions to math problems and chemical equations for us to kind of better understand and better understand and learn kind of concepts behind those questions. That's kind of my goal for this hour and for this session as well. Again, my name is Joey. I'm currently a secondary school educator in Ontario, and my subjects of interest are mathematics and chemistry as well. Before we get started, I'm just going to give you an overview of this hour. What we're going to do in this hour is we're going to tackle grade 10 math problems. So if you're tuning in from Ontario, we're going through some kind of quadratic equations solutions as well, and problems pertaining to those subjects. So we're going to do grade 10 math. And then if you're tuning in from the US, this will be probably the later half of Algebra 1 and Algebra 2 and the beginning of Algebra 2 here. So without further ado, let's get started. I see Carla in the chat. Says hi. Hello again. Thanks for tuning in again. All right, so let's work on these problems here. So it says, what is the first step to solve this quadratic equation? So we have x squared minus 40 equals 0, and then solve it. Okay, so let's write down here. I have, am I getting this? Okay, I gotta refresh the board here. That's okay. Let me just refresh the board. It sometimes does that. Okay. So I have here, this is, let's give it a sec for it to load. Here we go. We have here this x squared minus 40 equals 0, right? So again, how do we solve this problem when we look at this problem here? X squared minus 40. X squared minus 40 equals 0. So take a moment to think about this problem here. I only have two terms here, right? Usually our quadratic kind of equation I have here three terms, right? I have x squared plus bx plus x squared plus bx plus c equals 0. But in this case, we only have the x term and the c term here. So how will we solve this equation? How do we solve for x here? So it says solve for x. So take a moment to think about this problem here, and then we are going to take it up in just a minute here. So it says solve for x here. X squared minus 40 equals 0. And we only have two terms here. So what would this be indicative of here? So what we have here, we have your x squared minus 40. This looks awfully a lot like a difference of squares kind of term here, because we only have two terms here. We have a subtraction or difference here. This looks a lot like a difference of squares problem here. So when we talk about difference of squares, what do we mean by that? Well, we have, it's going to be, I have some term x squared minus some c term squared, right? So this would equal basically x minus c and x plus c here. So if we have here this x squared minus 40, then we can factor this and say this is, okay, this x minus, and then whatever the square root of 40 is. So minus square root of 40, and x here is positive square root of 40 here. And what we can do is we can actually break down the square root of 40 into a simplified radical term, right? So for us to do that, we have root 40. We have square root of 40 here. This equals, root 40 equals, this is, if I divide out root 2 times root 20 here, and then if I divide it again, this would be root 2 times root 2 times root 10 here, which is 2 root 10. So this here, if I were to simplify this out, I would get something like this. It would be a difference of squares equation, right? So x squared minus 40 would equal basically, this is x minus 2 root 10 and x plus 2 root 10. So which equals 0. And then what I can do is I can set this equation to 0, right? I can set this is it gonna write? Oh, there we go. X minus 20 2 root 10 equals 0, and then x plus 2 root 10 equals 0, and we're going to realize that here x has two solutions here. X is going to be plus or minus 2 root 10 here. So x will equal plus or minus 2 root 10 here. And this will be our solution for this problem here. As you can see, they also got x equals 2 root 10, but they only actually did one of these problems here. It's only the positive one, and they're missing the negative 2 root 10 here. When you factor this out, you get two roots. You get this one and this one as well. For this one, you get positive, and this one you get negative 2 root 10. So again, but in this case, they used the quadratic formula, and then they wrote plus or minus 2 root 10. So this here solution is correct. Is correct. Answer is plus or minus, basically, plus or minus 2 square root of 10. Solution can also be found using difference of squares, which is what I implemented to get the answer here. So solution here is correct. Okay, that's number 1. Yeah, that was number 1. Let's go on to number 2 here. It says, what is the center of a circle whose equation is the following? So we have a circle here, and we have this is x squared plus y squared minus 12x minus 2y plus 12 equals 0, right? So it's asking us, what is the center of the circle here? So what they're doing here is that remember our standard kind of equation of a circle looks something like this. They wrote it as t1 here, so maybe I'll copy that as well. That's fine. They have x minus, this is t1 squared plus this is y minus t2 squared equals the radius squared, right? The radius squared is where the r is the radius, and then t1 and t2 is the point at the center of the circle, right? So we have these two terms here, and what we can do is we can basically we're trying to factor out all of these guys here. So we're going to basically collect like terms and figure out how to actually get to this problem here. So I'm gonna rearrange this equation here to write x squared. I have x squared minus 12x plus y squared minus 2y plus 12 equals 0. I'm just putting the x's and the y's on the same side in this case here. And what we can do with this here is we can start factoring out specific things here, right? So we have x squared and x here, so we can factor out, we want to factor out basically this x squared minus 12x term. We want to factor out this y squared minus y term here. So in order for us to do that, basically we're doing something called kind of completing the square. So how they wrote it here is that they have x squared minus 2 times 6x minus 2 times 1, that's okay, plus 12 here equals 0, and they have x squared minus 2 times 6 plus x plus 6 squared, and then plus 1 squared here. So there's just simply taking the difference of squares here. So maybe I'll show you how they did it here. So basically they're taking these two terms and they're completing the square to make a perfect square trinomial, and they're taking these two terms and making a perfect square trinomial. So in order for me to do that, I have to do x squared. I'm gonna do this in black. Oh, it's frozen, so that's why. Okay, that's fine. I think this might be a Mozilla Firefox problem here. That's okay. So I have x squared minus 12x. I'm taking this b term and I'm going to divide it by 2 and then square it. So 12 divided by 2 here, 6 squared is 36 here. So 6 squared would be plus 36 minus 36 here. So I have that term first. And then I'm going to have, actually I'll put the 36 basically where this is, but actually no, I'll leave it here, plus, and then I have basically this here is y squared minus 2y. 2y divided by 2 is 1. 1 squared is simply just 1, right? So plus 1 minus 1 plus 12 here equals 0. And as you can see, basically I'm taking the negative terms out here. Basically I have my perfect square trinomial as stated over here. This here is a perfect square trinomial. This here is a perfect square trinomial. And these three terms, I'm going to have to these three terms here, I'm going to have to simplify here. So my perfect square trinomial in this case would be, this is x minus 6 here, squared. And then plus, I have here y squared minus 2y plus 1 is y minus 1 squared, right? And then I'm simplifying minus 36 plus 1 plus 12 equals 0 here. So I'm just going to rewrite it here. So minus 36 minus 1 plus 12 would give me minus 36 minus 1 plus 12 would give me a value of negative 25. Minus 25 equals 0. And then finally, I can move the 0 to the other side, and I would get x squared minus 6 squared plus y minus 1 squared equals positive 25 here, or I can rewrite that as 5 squared here. So my radius here I know is 5, and the center of my circle here is basically, this is 6 and 1 will be the center of my circle here. It's just simply taking T1 and T2, right? This is T1 and T2 here. This is my radius. T1 and T2 here, where basically the center of the circle is T1 comma T2 in this case, which is 6 and 1 here. So this here, the center of the circle, therefore, is 6 and 1. So this here solution is correct. Is correct. It's just missing the information that we have to complete the square for both the x terms and the y terms. And that's what they were doing in step 4, I believe it was this here is step 4 and step 4. The solution here is correct. I just want to explicitly say that they're actually completing the square, but it's totally fine here. That's number 2. Okay, so we have number 3 here. It says the graph of an equation with negative discriminant always has which characteristics? So number 3. So it has negative discriminant. Let me rewrite that here. Discriminant has what characteristic? So when we're talking about the negative discriminant, we're talking about this is b squared minus 4ac, right? B squared, remember our quadratic formula is x equals plus or minus b square root of b squared minus 4ac all over 2a, right? The thing in the square root here is this here is called the discriminant here. And basically it tells us the nature of our roots here, the nature of our roots. So discriminant talks about whether we have real roots or complex roots. So let me write that out. Discriminant tells us if we have real or complex roots. So in this case here, if we have a negative discriminant here, if we're trying to square root a negative number, in that case we're trying to square root, like if my discriminant here is negative, right? Which means we can say it's negative 1. Let's say our discriminant here was negative 1. So therefore I'm taking the square root of negative 1, which will give us I, which is a complex number here. I here is a complex number. Therefore, we don't have any real roots in the real plane. So you can say that in this case it's actually this here is option D is the correct answer, because negative discriminants just mean that negative discriminants means presence of complex roots. So which means there are no real roots. No real roots. So there's no x-intercepts, or no real x-intercepts here. No x-intercepts here. There's something in the complex plane, but not in the real plane. Don't worry about complex numbers. That's like much more higher level math. But basically, it's just saying that there are no real roots in this case, which means option D here is the correct answer. So you get imaginary roots, like stated here. Therefore, no x-intercept. Great solution. And analysis here. So the solution here is correct. Okay, that's question 3. Let's look at question 4. Question 4 states that determine the approximate volume of a sphere given a radius of 10 meters. So I want the volume of a sphere with, I'm going to say r equals 10 meters here. R equals 10 meters. So first I have to figure out how do you find my volume of a sphere. So in order for me to do that, I have to actually just, usually you're given a type of equation in terms of you're given equations of volumes or surface area. So we have V here. This will equal our volume of a sphere. You should be given this on an equation sheet. So V here equals 4 over 3 pi r cubed. And this is our this here is our kind of equation for the volume of the sphere, 4 over 3 pi r cubed here. So in order for us to solve it, we just simply have to sub in r to get volume, right? So r here equals 4 over 3 pi, and we have 10 meters cubed here. We have 4 over 3 times pi times 10 cubed here. 10 times 10 is 100, times another 10 is 1,000, right? So we have 1,000 meter cubed. And then finally, I just have to put this into my calculator, right? Again, 4 over 3 times pi times 1,000. My volume would simply would equal, let's see, 4 over 3 times pi times 1,000. This will give me a value of 4,188. 4,188.79, and this would be in meter cubed. And this here is the approximate volume of a sphere given a radius of 10 meters here. This is meters cubed here. So you can basically, if you're given meter, again, if you want to be specific and use significant digits, in this case, because we have one significant digit, I would just simply say 4 times 10 to 3 meters cubed here. And this would be my correct answer for this problem. They did the exact same thing here. V equals 4 over 3. Instead of pi, they did 22 over 7, which is the approximate value. I would actually just sub in pi in my calculator if needed. And then they basically calculated this. 4190.4 is awfully very close to this one here. So this here is a great solution analysis. I would use pi on a calculator instead of 22 over 7 to be more exact with the calculations here. So great solution, and solution here is correct. Okay, so this is 4. Let's do number 5 here. Kind of speeding through this one as well. This is good stuff here. So it's asking what number should be added both sides to the equation to complete the square, right? So I have x squared plus 12x equals 11. So in order for me to first complete the square, what I have to do first is I have to move 11 to the left side here. So I have x squared plus 12x, and then I'm going to subtract 11 from both sides, right? Which equals 0. So I have this here. This is my equation here, and they want us to complete the square, right? So in order for us to do that, what we're doing is we are, we are taking our b value, we are dividing it by 2, and then we're squaring it, right? So we have x squared plus 12x. 12 divided by 2, well, 2 here is 6. 6 squared is 36. So plus 36 minus 36 minus 11 here equals 0. So then, again, now we have our perfect square trinomial stated here. And then we have something left over. This will be the vertex form of our question here. So I'm gonna solve for this question here, but the answer is already 36 here. That's the kind of number to be added to both sides to complete the square. 36 here is our equation, but I'm going to solve for it anyways. Again, I have x squared plus 12x plus 36. This is a perfect square trinomial, so I know that here this is x plus 6 squared. And then I'm left with negative 36 minus 11, which is negative 47 equals 0. So this here is my vertex form, and I've successfully completed the square. And again, if I want to complete the square, I'm simply just adding 36 to both sides of the equation here. So 36 is our answer for this question, and they have here, therefore we add 36 to both sides to complete the square. This solution here is correct. We got the exact same thing, x plus 6 squared minus 47. And what we can do with this equation, if we want to make it like very similar to this one, is we can actually move 47 to the other side, right? We can say x plus 6 squared equals positive 47. And if you compare this with this one here, 11 and 47 has a difference of 36 here, and this solution makes it correct. So that's just double checking my solution here, but this solution is correct here. So great. Solution analysis here. Solution here is correct. So that's 5. We have more quadratic solutions here. This is question 6. It's asking x squared minus 40 equals 0. Wait, I think this is the exact same one. Give me a second here. This might be the exact same question. Did I double up by accident here? I might have actually doubled up here. Okay, so this solution was actually the same one that's given my first question here. So I think I accidentally picked up 2 of the same questions, but they wrote the exact same solution here. But if you want to review, it's simply this here is my solution. I'm just simply taking a difference of squares, and I am solving this equation. Again, I am doing, I can basically think of a square root of the x squared plus the square root of 40 here. So which means it's x minus 40 times x plus square root of 40. Sorry, x minus square root of 40 times x plus square root of 40. And then I simply just simplify my radicals here to get 2 root 10 here. So it's simply just x minus 2 times root 10 and x plus 2 root 10 here. So this solution again is correct. So I think I picked both of them on purpose actually, just to get those out of the solution bank here. So great solution and analysis, but this is again the exact same question as we did at question 1 here. Okay, so that was the same thing as question 1. So let me look at, that was question 6. So this here is question 7 now. We might have to end this video slightly early just because I did pick a repeat. That's probably my fault, but I might be able to pick another one depending on the time here. So it says here, find the solutions of the quadratic equation 9x squared equals 4. So we have, it's telling us to find the solutions here, right? So in order for us to do that, again, what we have to do with every quadratic equation is we have to put everything to one side, right? We want one side to equal 0. So I'm going to have 9x squared. I'm going to move 4 to the left side here, to this side here. I'm going to subtract 4 from both sides. So I get 9x squared minus 4 equals 0. Now, in order for us to kind of solve the solution here, what we can do is we can actually do a difference of squares again, right? I have 2 terms. I have a difference here. This here is a classic example of difference of squares. There are many ways to approach this problem, but difference of squares will probably be the most quickest way for us to solve for a solution here. You could plug this into quadratic formula and you get the same answer here, but in this case, I would do a difference of squares. So in order for us to do that, you can think of an imaginary square root on both these guys, right? So this one here and this one here. So if I were to square root both of them here, I'm going to have 3x for my first term, and then if I square root 4, I'm going to simply get 2 here, right? So if I were to write this out, I would get basically 9x squared minus 4 equals, basically I would have something, a term plus something, and then a term minus something here, right? So again, if I square root the first term here, I have 3x, which means this here is 3x, and then plus square root of 4 here is simply just 2, right? Plus 2 and plus 2 here. So I've found out my factors here, and this here equals 0 as well, right? So I have 3x plus 2 and 3x minus 2. And what I can do is I can then now solve for, I can split this up into 2 parts and solve for my 2 roots, right? So I have 3x plus 2 equals 0. And then 3x minus 2 equals 0, right? Let me write this down here. And then I have 3x minus 2 equals 0. So I'm solving for my first one here. This is x1, you can say. So I'm going to move 2 back to this side here. So I have 3x equals negative 2. And if I divide both sides by 3, I would get negative 2 over 3. Here is my first solution. And then 3x minus 2 out of 3x, I'm going to move 2 to the other side here, which becomes positive 2. Divide both sides by 3, I would get 2/3 here. So x would equal basically plus or minus 2 over 3 will be my correct answer here. So this here, again, they got the same solution here. This solution here is correct. Again, they did something like, they just took the square root of both sides, I believe, which is the exact same thing as the difference of squares. Totally fine. And they got, yeah, so they put 4 over to the other side. So they did basically, instead of doing difference of squares, they looked at it as, they just solved for it algebraically. So I'm going to show you what they did here. So they have 9x squared equals 4. What they did was they moved 9 to the other side. So if x squared equals 4 over 9, and simply just square rooted both sides here, which would equal 2 over 3, plus or minus 2 over 3. So this solution, again, actually this is probably even a faster solution than what I did here, but I solved for it based on difference of squares. They visualized it as algebra. It totally is fine. Honestly, both ways work as long as you get the same answer here. So this is plus or minus 2 over 3. So this here is a great solution and analysis here. So both ways work as well when solving quadratic equations, right? We can solve by factoring, solve by algebra, solve by inspection, quadratic formula. All of these are basically tools for us to solve for a quadratic equation here. So the solution here is correct. So let's see what my next question is here. Another quadratic equation, so this is number 8. Lots of quadratic equations today because I honestly that's basically grade 10 math. A lot of work with parabolas, a lot of work with completing the square, factoring, quadratic formula, using discriminants. A lot of these guys are basically like different like quadratic equations here. So I have x squared equals -7 minus 8 here, and I'm going to again move everything to one side here. So I have x squared plus 7x plus 8 equals 0, right? And this here will give us our quadratic equation here. So how can we factor this? What can we do to this equation to kind of solve for this? Well, let me just think about this question here. What we can do is we can solve by inspection first and see if it factors out, right? So again, I have a here times c. So I have 1 times 8 here, which is simply 8. So I need a product of 8 and has a sum to 7, right? Sum to 7 here. So product of 8 that sums to 7. My factors of 8 are simply just 1, 2, 4, and 8, right? 1, 2, 4, and 8 here. And I don't think a combination of these values are going to sum to 7 here, because I need a positive number here. So in this case, I can't use factoring by inspection here. And again, I'm going to have to use the quadratic formula for us to solve for this problem here. So therefore, even if I took 8 and 1 and summed it, I would get 9, right? So I wouldn't get 7 here. So again, I cannot factor by inspection. So therefore, I'm going to have to use the quadratic formula, right? So this again, I have here x squared. Let me rewrite this here. Squared plus 7x plus 8. I'm going to have to use the quadratic formula. So this would be plus or minus b square root of b squared. Sorry. Yeah, plus or minus negative b plus or minus square root of b squared minus 4ac. Did I do the quadratic equation wrong for my other problem? I'm trying to think about it now. I think I wrote it wrong. Yes, I did. It's negative b here. Whoops. I swear I wrote it wrong here. Classic mistake here. So let me change this up here. So this is negative b plus or minus. Sorry about that. Okay. Let me go back. So negative b plus or minus square root of b squared minus 4ac all over 2a, right? So this here is my quadratic equation here. And again, negative b, again, I have 7 here, right? 7 is my b value here. Square root of b squared, which is 7 squared, minus 4 times a here is 1 times 8, all over 2 times 1 here. And now I have, let's look here, I have negative 7 plus or minus the square root of 7 squared here is 49, minus 4 times 1 times 8 will give me a value of 32, right? All over 2 times 1 here is 2. And now I have, in my square root, I have here negative 7 plus or minus the square root of 49 minus 32 here is 17, I believe, all over 2. And now I can simplify, and I can basically break this problem down into 2 components here. I have x1 and x2. So x1 would be negative 7 plus root 17 over 2, and x2 would equal negative 7 minus root 17 over 2 here. And this here will be my solution for the problem here. So negative 7 plus root 17 over 2 and negative 7 minus root 17 over 2 here. So this solution, again, here is correct. Again, they solved for it by decimals. Again, I could plug this into my equation or into my calculator, and I'll get the exact same thing. But basically, the solution here is correct, right? -7 plus or minus square root of 17 over 2 is exactly what I got here. So this solution here is correct. So great solution and analysis here. And I'm just going to double check on my calculator that actually equals -1.4 here, but I'm pretty sure it does. So let me just bear with me for a sec. -7 plus root 17 divided by 2 is -4.3. That's good, which is the first guy there. And the second value would have been -5.56, which is actually not the solution here. This solution here is incorrect here. -7 minus 17 root 2. Oh yeah, so their second decimal here is wrong, right? -7 minus 4.12 divided by 2. It's 5.56. So actually, the solution here is wrong. Good thing I double checked here, because this -4.06 does not exist here. So I'm going to say solution is incorrect. Is correct up to the last step. Correct up to the last step. X should equal -1.44, and it should equal basically -7 minus 17 over 2 would be -5.56. 5.56 here. Great analysis though. Solution here is incorrect here. The correct answer is -1.44 and -5.56. The solution here is incorrect. This question was the exact same thing as I did for a previous question. I remember doing this question as number 7 here, which is whack. So again, I definitely picked the same question here just to verify the solution here. It's again plus or minus 2 over 3 was our answer here, right? So again, what we're doing here, you can use algebra and basically move 9 to the other side, and this simply just square root both sides to get square root 2 over 3, or plus or minus 2 over 3, sorry, and this will be our answer for this problem. Or you can visualize it as a difference of squares kind of question here. So again, I'm going to say here, this is great solution and analysis here. So I picked 2 overlaps now, actually. So this is that was question 9 here. So 9 was the same thing as 10. So it's the same as question 7. I think I only picked 2 more questions for today. So maybe I'll finish off this problem with 2 here. The 2 problems here. And then we'll call it a day here. So it says, what is the sum of the polynomials 7x cubed minus 4x squared and 2x cubed minus 4x squared? So it says 7x cubed minus 4 minus 4x squared, and I have 2x cubed minus 4x squared here. And it's asking us to sum these polynomials. So when we talk about sum, we're adding these two polynomials, right? So we're saying we have 7x cubed minus 4x squared plus 2x cubed minus 4x squared, right? So if we're adding polynomials, again, all we're doing is we're taking like terms. So again, what we have here is we're adding these polynomials together. Wait, let me just see if I did this correctly here. Yeah, so I have, again, so I'm collecting like terms here, right? So I have basically 7x cubed and 2x cubed here. 7 plus 2 here is 9x cubed. And then negative as 4x squared minus negative 4x squared would be negative 8x squared. So the solution here is correct, right? So therefore, they wrote 9x cubed minus 8x squared, which is exactly the same thing as what I got, right? We're simply just adding these two polynomials together, right? So this here is the addition. Again, 7 plus 2 is 9. Negative 4 minus 4 is negative 8 squared. Negative x squared, sorry. So this solution, again, great solution and analysis here. Solution here is correct. And finally, I have one last question. Which of the following? I'm not given the triangle here. I can't really see this actually. Whatever this GIF file is, I can't really click it. Weird. Okay, so I actually can't verify the solution because I don't know what this solution is. But let me try to actually, based off the solution, let me try to draw out the triangle for you. I wish they included a diagram in the solution, but they didn't. So let me just try to figure it out. Which solution is true? So this is, so I'm going to find a true statement, and based off that, I'm going to see if I can derive the triangle for you here. So I have a right triangle for sure. This is cosecant. So cosecant right triangle C, so angle C would equal cosecant of, this is B here. Cosecant right triangle C equals right triangle C, right triangle equals 3 over 2. Okay. So if I'm saying that, let's assume that this here is C, this here is A, this here is B here. I think actually no, A is, B here is, yeah, B here is this guy here. B here is this guy, and A is here. So I'm saying cosecant C equals 3 over 2, and they said it was a true statement. So based off this true statement, I'm going to see if I can redraw the triangle for you and explain this question here. So cosecant angle C equals 3 over 2 is the exact same thing as saying 1 over sine, right? Cosecant is a reciprocal trigonometric ratio over here, right? Cosecant angle C is simply just 1 over sine root C, right? So when we say that if it's the reciprocal of sine, and we know that sine here is opposite over hypotenuse, right? Opposite over hypotenuse. Don't know if my pen's not working. There we go. If sine, we know that is opposite over hypotenuse, then cosecant would be hypotenuse over opposite, right? This is simply just the reciprocal of this guy here. So if it's the hypotenuse over the opposite here, and we know that this statement here is true, so this is 3 over 2, right? So 3 would be our hypotenuse in this case, would be 3, and the opposite would be 2, right? Again, because this is angle C here. So this would give us a some sort of triangle here. And then what we can do is we can use Pythagorean theorem to figure out what this side here is, what the side length here is as well. I think that there might be other 2 triangles here. Triangle B is cosecant is 6 over 5. There might be actually 2 triangles here. Yeah, there might be 2 triangles here. I'm not sure what question they're asking here. But again, because I can't access this GIF file here, so I'm assuming that this is what they're asking. They're asking me here. And what we can do is we can again use Pythagorean theorem to figure out the side length here, and I'll do that quickly here. So I know that. Let me do some blue here. This is simply just c squared equals a squared plus b squared. So c squared I know is 3 squared equals, again, I can assume this is 2 squared plus b squared here. I can move 2 squared to the other side. This is 9 minus 4 equals b squared. So b would have to equal 5 equals b squared here, which means b here equals root 5. So this side length would be root 5 for this triangle here. And I'm pretty sure that because this statement is also true, cosecant triangle B is 6 over 5, then I think this might be referring to a different triangle, because again, I don't have 6 or 5 in any of these side lengths here. So this here, again, I'm pretty sure that again, I can't verify the solution per se to say that this solution here is correct, but I'm going to assume that this solution here is correct, and that these are my triangle lengths here. This was the given triangle for triangle C here. This would have been triangle C. Let me label that here. Triangle C here. So this here would have been the correct solution, or the correct triangle for basically this Waterloo solution here. So this here is, again, question 11. Again, I still have about like 20 more minutes. So what I'm going to do is I'm actually going to see if I can figure out more. I didn't know I picked actually 2 repeat kind of questions. So what I'm going to do is I'm actually going to go into my list of questions here and pick out some more grade 10 questions for you as well. So let me do that really quick before I continue here. So I'm going to say cannot see triangle. Solution seems to be correct. So what I'm going to do is I'm going to pick out, maybe I'll pick out about 2 more problems for us to do since we do have about 20 minutes here. So let me do that real quick. Let's see. Because I usually only pick about 11 questions per my stream. So because I didn't know, we doubled up today. So I'm going to pick maybe 2 more questions for us to do here. So I'm going to pick these 2 questions here, and I'm going to bring them up to you shortly. Just give me a second here. Sweet. Okay, this sounds good. I'm going to say finish here, and then I will start the stream. And this will give me another question like so. So this is here as question, basically back to question 1 again. We will finish this stream off with these 2 questions here. So this is what value must be added to x squared plus x to make it a perfect square trinomial. So I have x squared plus x, and I want to make it a perfect square trinomial. So what am I going to add here? Plus c to make it a perfect square trinomial. So in order for us to do that, again, this is simply just another completing the square kind of question here. This is completing the square, right? You can think of this as completing the square, or you can think of this question as what value what value of c in order to make it a perfect square trinomial, right? So I think of it as completing the square because I'm taking because completing the square requires a perfect square trinomial for us to simplify it. So if I have to do completing square, I have x squared plus x plus c here. I'm looking at the b term here. The b term here is simply just 1, right? So my b here equals 1. What I'm going to do to this b term, I'm going to divide it by 2 and square it. So b here with the new value here would be 1 divided by 2, which is half. And then I'm going to square this value here, which would equal 1/4, right? So in order for us to complete the square here, I would have to put x squared plus x plus 1/4 minus 1/4 here. So that in order for us to do that, then we would get our perfect square trinomial here. So assuming that this here equals 0 and this here equals 0, this guy here, I'm going to do this in blue, this would be my perfect square trinomial here. And this will give us simply just x plus half of x here squared minus 1/4 would equal 0. And this here would be my solution for, this is not my solution here. It's x actually just plus half here. Half squared minus 1/4 equals 0. This here is my perfect square trinomial for us to add to get a vertex form. So I'm completing the square here, which means therefore I would have to add here. My value to add here would be 1/4 here to make it a perfect square trinomial. So this here, therefore 1/4 must be added to the expression. So the resultant trinomial is a perfect square. So this solution again here is correct. It's correct. Great analysis here. So again, the takeaway here is when we're completing the square, we're taking our b term, we're dividing it by 2, and then we're squaring that term, and then we're adding it to both sides for us to create a perfect square trinomial. So again, if we have 1 here, dividing it by 2 is half, square that is 1/4, and we're basically adding 1/4 to both sides for us to figure out whether or not, basically what number to add to this kind of binomial here to get a perfect square trinomial. So the solution here is correct. That's great. And then our last question for the day is a systems of equation problem. So let me just draw this out first. So it says a systems of equation is shown below. What is the value of x in the solution of the equation here? So I have here, this is y equals 2x plus 3. And I have y equals negative 4x plus 21 here. So again, it's asking us what is the value of x in the solution of the system, right? So in order for us to solve for a system of equations, what we have to do is we can either do substitution or elimination for us to get rid of a variable. Right now we have x and y, right? We have x and y in both of our solutions here. And we want to get rid of one variable here for us to solve for an x value here. So in order for us to do that, again, I would actually get rid of y here because I already have everything's already algebraically done for me. So I would simply just use substitution here. So I have 1 and 2 here. I'm basically going to say that I'm going to say sub 1 into equation 2. So in order for me to do that, once I sub equation 1 to equation 2, I would basically get 2x plus 3 here, and this would equal negative 4x plus 21. Plus 21. I'm equating the y values, which means my y values cancel out. Therefore, I only get one variable here, and we can easily solve for a one variable equation through this value because we're solving for x here, right? So again, what I can do is I can add 4x to both sides. So I've got 2 plus 4 here is 6x plus 3 equals 21. And then I can move 3 to this side. So I'm subtracting 3 from both sides here. 21 minus 3 is 18. And then I can simply divide both sides by 6 here to get me a value of 3, right? I can divide both sides here. 6x divided by 6 here is simply just x. 18 divided by 6 here is 3. So x here equals 3 will be my solution here. If I were to extend this problem and say, can I find the point of intersection between these two lines here, I would simply just have to sub 3 back into this equation here. So let me just do this problem here. So I have x equals 3, which is basically the solution here, and the solution is great here, so that's fine. But if I were to extend this problem and say, what is the point of intersection between these 2 points here, I would have to figure out a y value, right? So right now I have 3 and y, right? And what I have to do is I have to plug in this point into any of these equations here. So I'm going to say maybe equation 1 here. So I'm going to do this in red here and say I have y equals 2x plus 3. And I can simply just sub in 3 for my x value to figure out my y, right? So y here would equal 2 times x here equals 3 plus 3 here. Y would equal 2 times 3 here is 6 plus 3. And the y would equal 9. So which means the point of intersection, so the POI of these two systems of equations here are 3 and 9 here, right? And what we can do is we can actually graphically check this out. So let me just do that for you real quick, and we will end the video there. When we talk about systems of equations, we are solving for point of intersection. So this here is 2x plus 3. Again, we have a linear line like so, and we have negative 4x plus 21. And as you can see here, this point the point of intersection when we're solving for this will be point 3 and 9 here. The exact point is 3 and 9 here, and this here is my solution, right? The point of intersection is 3 and 9 here. The question is also only asking us what is the value of x. And again, what the value of x is the solution is simply 3 here, right? And that's what we solve for in this equation here. We simply use the substitutions to solve x equals 3 here. However, what we can do is, again, we can extend this problem and say we're solving for our y value as well. We simply just plug in x value into one of these equations, either 1 or 2. Both of them will give us the exact same answer, and it will give us y here equals 9. Therefore, our point of intersection is simply just x comma y, so it's 3 and 9 here. And as shown graphically, if you were to graph out 2x plus 3 and negative 4x plus 21, you would get 3 and 9. And this is the point of intersection in which the two linear equations intersect at. So we solve for this systems of equations here. So the point here is 3 and 9. So let's look at the solution here, and we'll end the video here. Again, what they're doing is they're doing elimination. So they're subtracting the y here. So they're canceling the y to just solve for our x values here. They have 2x minus 4x, which is 6x. And then 3 minus 21 here is negative 18. And then they simply just divided both sides by 6 here, and they got x equals 3. So this solution here is correct. Solution is correct. Can also use substitution to solve for systems of equations, but elimination works as well. Can also extend problem to solve for point of intersection for the two linear equations, and this would be 3 and 9 here. That's the point of intersection here. So POI would equal 3 comma 9 here. So this here solution here is correct, and this will end my video for today. We'll end a bit early, as I said before, but thank you so much for watching for my video here. Again, we've done today we did basically 11 questions, because again the 2 are repeats as well, so I'm sorry for that. thank you so much for watching the stream. Again, I'm streaming. My name is Joey again. I'm streaming from basically Monday. I'm streaming from Monday to Friday. Monday and Wednesdays and Fridays are going to be math problems, and Tuesdays and Thursdays will be my chemistry problems as well. And I'm streaming 5 days a week, so feel free to tune in as well. Again, thank you so much for watching. As always, stay safe, stay healthy, and have a great day. Take care.